All right, let's look at some examples of how the quadratic formula works. So the key to remember here is that we always have to have our equation in standard form before we can use the quadratic formula. So we need to have ax squared plus bx plus c equals 0. And once we have that, then we can use the quadratic formula that says x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right. So first thing here, we got to subtract 4 from both sides. We want it to be equal to 0. 2x squared plus 3x minus 4, not 4d. Get rid of that. All right. And now we're ready to go. We've got our a value, our b value, and our c value. So we can plug that in. X equals negative b, and b is 3 plus or minus square root 3 squared minus 4 times a times c. Don't forget to put that negative 4 with your c all over 2a. And now we just do some careful arithmetic. On the inside we have 9, and we have negative 4 times negative 4, which is 16, times 2. So that's going to be positive 32 all over 4. So we can simplify that a little bit more, but not much. It's going to be a square root of 41 all over 4. That is the final answer. Now this represents two answers here. This represents negative 4 plus square root of 41 over 4, and x equals negative 4 minus the square root of 41 over 4. If we were working out an application problem, we'd go plug that into our calculator and get a decimal. Or if we were graphing or something like that, same thing here. All right. This is an exact answer. The decimal value you would get would be an approximate. You can also check it on your calculator, and it should match up with the decimal approximate. So this one already is in standard form. It's already equal to 0. So we can go straight to the quadratic formula. X equals negative b plus or minus square root. Our b here is negative 12 squared. Now, that really belongs in parentheses. This is always going to come out to be a positive number in this part. That'll never be negative. So that's a mistake that sometimes happens. All right, all over 2a. Again, take the time to write it out. And we end up with 12 plus or minus. The square root of 12 is 144. Again, this will always be a positive number. You'll never, ever have a negative here. If you've got a negative here, you did something wrong. But here we have, 4 times 4 is 16, times 9 is 144, and really negative 144, because that negative there, which is a minus sign. And what happens? We end up with 12 plus or minus the square root of 0, which is 0. So this is really just 12 over 18. Okay, because 12 plus 0 is 0. Is 12. 12 minus 0 is also 12. So we don't have to add and subtract 0. We can simplify this fraction, though. 6 goes into both, it's 2/3. So we get one answer. So it's possible to get two answers that are irrational because they have a square root in them. It's possible to get one answer. And let's look at a couple more situations here. So here we can add 2 to both sides. We need to make it, get it in standard form first. All right, equals 0. And now we can go to our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And we work it out. We got negative 4 plus or minus 16 minus 16 all over 4. Well, this comes out to be kind of the same situation. 4 times 2 times 2 is 16. So again, this is negative 4 plus or minus 0, which is just going to be negative 4 over 4, which is negative 1. One answer there. And one more situation here. Subtract 5t from both sides. 2t squared minus 5t plus 4 equals 0. Now we're ready to go. Now this is a t, not an x, but that's okay. Doesn't matter what the letter is. It's still in quadratic form. It's t squared, t to the first, and a constant, no t at all. So it still works. It's just going to be, instead of solving for x, we're solving for t. Equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 5 plus or minus the square root of 25. And this is going to be 4 times 2 is 8 times 4 is 32 all over 4. And so we end up with 5 plus or minus the square root of negative 7, right? Yep. So we got a negative. So that means we have an imaginary number here. The square root of 7 we cannot simplify, but we can pull that negative 1 out. It becomes an I. Square root of negative 1 is I. And then that's pretty much it. Now, the last thing we might like to do, because it is a complex number, is let's divide both of these by 4. Divide the square root of 7 by 4, which is square root of 7 over 4. And we have I. And that's the form that we prefer to have complex numbers in. The standard form for a complex number, all right? So, the key is when we're solving quadratic equations, we have several different methods. So here's a quick summary here. If we have if b is 0, in other words, if there's no x term, then you're just going to use the square root method, okay? If we can factor it, then go ahead and factor it if it's factorable. That makes it a lot quicker and easier, okay? If it's not factorable, then we go straight to the quadratic formula or completing the square, all right? So you choose, depending on the situation. Sometimes completing the square can get a little ugly, so the quadratic formula is a little nicer. Sometimes completing the square is really easy, though. So let's think about this here. Let's decide what method would be best to solve these quadratic equations. Then we'll just kind of think about the first step. We're not going to solve the whole thing, okay? So what's the best method here? Well, we ask ourselves, can we use the square root method? No, because it has an x term. Can we factor it? And we can factor it. So if we factor this, we can pull out a 5x. Now I know this is a little different form. Sometimes we forget this, but don't forget that we can pull out a common factor. 5x goes into here, x times. 5x goes into here, 5 times. If you distribute this out, you'll get right where we started. Okay? So this is now factored. So I know we said we weren't going to finish it, but the idea for finishing it is either 5x equals 0 or x plus 5 equals 0. Here, divide by 5, x is 0. Here, subtract 5 from both sides, and we get negative 5. So a little different kind of factoring. You know, we're used to kind of trinomials, but don't forget, you can factor that binomial by looking for a common factor. All right. Can we use the square root method? No, because there's an x term. Should we try to factor it? I don't think so. Not with the 12 and the 7. So we're going to want to go ahead and use a quadratic formula. X equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Okay, and we'll pause there. And how about this one? Notice there's no x term. So this is a good one for adding 20 to both sides. And we get 35x squared equals 20, and so on and so forth. So this is the square root method is what you want to use. All right, and eventually at the end we'd end up with an x squared equals something, and we'd square root. Okay, so we got the square root method, we got the quadratic formula here. And we've got factoring. So those kind of our main ones, our main methods. Completing the square works nice, but sometimes it's just more work to do that, so we usually go right to the quadratic formula. So, well, there's some examples. Hopefully that gives you an idea how the quadratic formula works.